So today we're going to be verifying inverse functions. Now, inverse functions, we've spoken about these before, are going to be functions that undo the other function. Everything one does, the other does the opposite. Now, we have to be very careful about this because some functions can appear to be the inverse and they're not. Some functions, when we look at them, I see times 5, divide by 5. I see add 5, subtract 5. I see plus 1 times 2. I see minus 1, divide by 2. Some can be the inverse, and they might explicitly look like it and be. Some might explicitly look like it and are not. So the only real way to tell is we have to compose the two functions. And the way that we do that is we're going to take one and plug it into the other. So if I'm going to take g and plug it into f, let's say g is the inverse, I should get the answer of x. I will get a single x. That means g is the inverse of f. If I compose it the other way around and take f and plug it into g and I also get an x, then f is the inverse of g. Sometimes this is not a two-way relationship, it's just a one-way. The other one might not be able to produce an inverse. If both functions produce y equals x, then that means they're a pair of inverses. So without further ado, let's go ahead and jump into the first one. We're going to see if these functions are inverses of each other, and if they both are, then they're paired inverses. So let's give this a shot. So if f is 5x and g is 1/5 of x, let's take g and plug it into f. So the first thing we're going to try is I'm going to say f of g of x. I'm going to take g and plug it into f. Okay, so we are going to do, let's do f in red, and let's do g in blue. Just kind of help us spot this. So I'm going to take f, which is going to be 5x, and inside of that, I'm going to plug g. So let's say 5, and my g is going to be 1/5 x. So if I evaluate that out, I get, okay, 1/5 of 5 is 1. I get an answer of x. So what I know is that g is the inverse of f. I know that. The next thing I'm going to try is I'm going to try it the other way around. I'm going to try plugging f into g, which means I'm going to go ahead and I'm going to say, okay, g of f of x. And I'm going to start out with the other function. So I'm going to start out with 1/5 x and see where this takes me. Well, it's going to be 1/5 of f is going to be 5x. 1/5 of 5x is going to be x. So now f is the inverse of g. So what I know is that because they both produced a value of x, g is the inverse of f, f is the inverse of g, we have paired inverses. Awesome. Let's try one more. So when I look at this one, again, I see a plus 5, minus 5. I'm very inclined to think that, hey, this looks like something that should produce some paired inverses. So let's give it a shot. I'm going to do the same thing as before. I'm going to take f, we're going to make it red. I'm going to take g and make it blue. I'm going to try out f of g of x. And I'm also going to try out g of f of x. Okay. With the g of x, we're going to start out with x minus 5. And with the f of x, we're going to start out with x plus 5. Should have done that exactly backwards. That is my g of x is x minus 5. I'm plugging that into my f, which is going to be plugged into this x plus 5. I'm going to write that out as blank plus 5. There we go. That kind of covers up my little blunderbuss here. So my f of g, let's see, that's going to be an x minus 5 plus 5. That will give me an x. So what I know is that g is the inverse of f because of that. I'm going to do my same little kind of auto correction here and plug that into my blue equation because that's what I should have started with. So I have a blank minus 5, which is what I'm plugging in. X plus 5 minus 5, which is going to give me a x. And so now f is the inverse of g based off that information. So again, we have ourselves a nice little paired inverses. I'm not sure why inverses is so difficult to write, but I'm struggling with it right now. Okay, perfect. So now that you've seen one or two, why don't you go ahead and try number 5 on your own. Pause the video and pause it when you're done and see all you did. Okay. So now that we've had a shot, we're going to do exactly what we've been doing. I'm going to take f and I'm going to plug g inside of f and see what we get. And then I'm going to take g and plug f inside of g and see what I get. I'm going to make f, just because we've been doing it this way, red, and I'm going to make g blue. Okay. So here I'm going to fix what we did previously. I'm taking x, plugging into g, and g plugging into f. So because I'm plugging g into f, I'm going to start out with my f, my 2x plus 1. What am I plugging into f? It's composed of g. So I'm going to rewrite it. Well, it's composed of g, which in this case is x minus 1 divided by 2. And I'm going to see what we get. Okay, so that 2 divided by 2 cancels out. I'm left with x minus 1 plus 1, which is x. So f of g of x works. So now g is the inverse of f. Good stuff to know. Next, I'm going to take my g, and what am I going to compose it with? F. So let's start with g, which is going to be x minus 1 over 2. So let's leave a big old blank up here, minus 1 all over 2. What am I plugging into g? F. In this case, f is going to be 2x plus 1. So the first thing I notice is that my plus 1 minus 1 cancel out, if I'm following order of operations here. So I'm left with 2x over 2, in which case I'm left with x. So g of f of x works out. F is the inverse of g. So we have, again, paired inverses. Boom. There we go. And so we seem to get the idea that if we produce an x, good things happen. We also know that from what we've seen is they tend to be doing opposite operations. So let's take another look at this. I have a times 3 minus 7. I have a divide by 3 plus 7. This looks like it should be the inverse, so why don't you go ahead and pause the video, try out number 7, and see if that proves accurate. Okay, so let's take a look at this. So I'm going to take f of g of x, and I'm going to take g of f of x 2 times, and I'm going to plug these in. I'm going to keep the same color pattern. I'm going to make f red and g blue. I'm taking f, and inside of f, I'm plugging in g. So I'm going to start out with my f, which is 3x minus 7. So I'm going to leave some space and say 3 blank minus 7. And this should all work out nice and dandy. 1/3 x plus 7. Now, what you might be tempted to do is the plus 7 minus 7 is cancel them out, but don't forget, I have to deal with parentheses first. So 1/3 of 3, that cancels out. I have x, and that 3 times that 7 will give me a 21. So what I run into is 21 minus 7. I get an x plus 14. So my f of g of x produces this answer. So I know that g is not the inverse of f. It looked like it, but I did not get an answer of x, so it is nothing special. It's just another function. They look similar, but when you work them together, I don't get my necessary x as the inverse. So g is not the inverse of f. Nope. But there's still a chance f might be the inverse of g, so let's go ahead and give that a shot. So I'm going to start out with g, and what am I going to plug into g? F. 1/3 of x plus 7. So 1/3 of this big old space plus 7. Let's plug in a 3x minus 7. And so again, be very careful. A lot of people see plus 7 minus 7 and try and cross these out. Remember, if they're inside parentheses, I can't just willy-nilly add them. I have to distribute whatever's going on before I can add or subtract across parentheses. Parentheses are literally there to say, don't do that. So let's not do that. So 1/3 of 3 is x. So far it looks so good, but here's where it starts falling apart. After I distribute that 1/3, I get a minus 7/3 plus 7, which means that that's plus 21/3. So that's going to be plus 14/3. And so here we know f is not the inverse of g. So these are both nothing special. G is not the inverse, f is not the inverse. It looked like it. It looked a lot like some of these where I had plus 5 minus 5, I had times 5 divided by 5. This worked out, this worked out, this didn't. So where's the catch? Well, what we noticed in this one was even though I had a times 2 plus 1, I reversed the order. Here I didn't have a divide by 2 minus 1, I had a minus 1 divide by 2. Not only did I reverse the operations, I reversed the order. If I plug something into x, I multiply and then I add. So let's reverse that. Reversing the addition would mean I subtract first, which is what we see in the next equation. And then if I reversed the addition, I would have to undo the multiplication, which is what we see second. So be very careful when we see things like this. We're not just reading left to right and saying, well, times, minus, divide, add, all good, because clearly this did not work out. So let's go ahead and pop off into our next set of problems. So take a quick peek and look at this one. We're going to take a look at number 9. Now number 9, what I see is that I see a times 5 divided by 3 times 3 divided by 5. This looks like it's good. So when I go and try and do this and I say f of g of x, g of f of x, I'm going to start out with my f, which we're going to keep red, and we're going to keep this blue. Start out with my f, and I'm plugging in g. So I have negative 5/3 x, which means negative 5/3 of the other thing. So let's see, that is negative 3/5 x. Awesome. This looks like it works out pretty well. The negatives cancel out, the 5s and the 3s, so I'm just left with a positive x. So g is the inverse of f. Awesome. If I tried the other way around. Now, this also, when we saw the double negatives, you may or may not have been hesitant to say that they are inverses. So I'm going to take, starting out with g, so I'm starting out with the negative 3/5, and I'm going to plug in negative 3/5, leave some space to plug in my f, which is negative 5/3. Negatives cancel out, so do the 5s and the 3s, and I'm left with an x. Awesome. So I have that. So now that f is the inverse of g, we have ourselves a good old-fashioned paired inverses. Perfect. So multiplication and division, even if the signs don't change, good things can happen. So now what I want you to try and do on number 11, I want you to see if you can just look at the equations and tell, are they going to be inverses? Well, if you're looking at them, what I see is the fact that it looks like I have a, if I were to follow the x's path, times a negative 1, add a 7, divide by 2. Down here, if I follow the x's path, I would add a 7, and then times by negative 2. I can't necessarily see if I can walk my way out of this. So the orders aren't necessarily lined up, so it may or may not look like this is good. I see a lot of the same numbers, which is nice. I see 2s and I see 7s. I see negatives and pluses, but that's a lot of things that are the same. The only way to try it out, or the only way to figure out, is to just go ahead and plug them in. So I'm going to do this as blue and red again. I'm going to do my two functions. So I'm going to take f of g. I'm going to take g of f. Oop, there we go. So if I'm starting with f and I'm plugging in g, or if I'm reading from right, I'm taking g and plugging it into f. I'm going to take my f and say negative x plus 7 over 2, which is negative this thing plus 7 over 2. I don't know why I made my parentheses taller and not wider, but we'll go with it. So I'm plugging in g. So negative 2x plus 7. Okay. So if I work my way out slowly, what I see is the fact that the x plus 7, I have to distribute the negative 2. So negative 2x minus 14 plus 7 over 2. The next thing as I work my way in is I'm going to distribute that negative in there, which gives me a 2x plus 14 plus 7 all over 2. And so what I'm seeing here is that I end up with a 2x plus 21 all over 2. That's not simplifying down. So my f of g, I know that g is not the inverse of f. So g is not. I'm not going to write out all that because I don't really have a whole lot of room for it. But I know g is not. Let's try f. Maybe it works out the other way. Okay. So if I take that and I start out with g, I have a negative 2x plus 7. And I'm going to plug in my f into that. And so I'm actually going to scooch over here to give myself some room because I'm about to take up a lot of space. Let's leave some space in there for that. And I'm plugging this value in there. So negative x plus 7 all over 2. Okay. And so now I'm going to slowly work my way out. Now what I could do, I've got a couple paths I could take here. I could try and add the 7 to this and make one big fraction. But I think the best way that we can do this is distribute the negative 2. Because the 2 and the 2 are going to cancel out, and that's just going to mean that that is a negative times that negative x plus 7. The negative 2 over here, once I distribute to the next piece, it's going to make a negative 14. Should be my negative in there. X minus 7 minus 14 is x minus 21. So what I know here is that f is not So these are nothing special. Again, it looked close, it looked very similar, but neither one of these is the inverse of the other. Cool. So number 13, try a shot at number 13, pause the video, unpause it when you're done, and see all you did. Okay, so now that you've had a shot to try it, we're going to go with the tried and true fashion here. Looking at it, I kind of see a similar setup as before. I see 7s, I see 3s, I see minuses and negatives. It looks like this could be good, but we're not sure. So when we're not sure, we just go ahead and we try it out. So I'm going to take my F and plug in my G. So my F was negative x minus 3 over 7. I'm going to say negative, leave a big ol' space, minus 3 all over 7. The big ol' space is going to be filled up with negative 7 minus 3. And let's get to working. So if I work my way inside out, I'm going to distribute that negative in first. So 7x plus 3 minus 3 over 7. Now, it might be tempting to just go ahead and slash these both out in one step. Remember, we have to take it piece by piece. So the 3's cancel out, so I have 7x over 7, which leads me to x. So G is the inverse of F. G is. That's going to be our abbreviation for G is the inverse of F, because there's no room. Now we're going to flip it and say G of F of x. I'm going to start out with the other equation, negative 7x minus 3. I'm going to scooch this over, so negative 7, leave a big ol' space, minus 3. Negative x minus 3 over 7, and see where this goes. Okay. Distribute the negative 7. That's going to make the negative is the only thing that's going to carry through on the top. The 7's going to cancel out. So I'll have a negative x minus 3, minus 3. Again, be careful. Don't combine these 3's just yet, because I still have to work in that negative sign. And so I know F is. Perfect. I have ourselves a good old set of paired inverses. And so one of the most common things that we get at this point is that all the examples we've seen, everyone up until this point, I see that we have paired inverses, neither of them worked. Paired inverses, neither of them worked. Paired inverses, paired inverses, paired inverses. So it looks like if one works, the other does, and if one of them doesn't work, neither of them works. And while that's a good thing to carry through when we have linear equations, we don't want to do it with anything that is not linear. These are curves. So with a curve or a quadratic, we can't make that assumption. Why? Well, if you wanted to, try and work this one out and see what you get when you work both ways. You should get that one is the inverse of the other, but not the other way around. So see which one is the inverse and which one is the fake one. Okay. Let's give it a shot. We're going to do F in red and G in blue. And we're going to see our first non-paired, non-cooperative, I guess would be the right word there, set of functions. So I'm going to say F of G and so my F, I'm going to start out with red, is x plus 2 squared. I'm going to leave a big ol' space right here, plus 2 squared. So I can plug in my G, which is root x minus 2. I'm going to slowly work my way out here. So the root stops over the x. It's not over the 2. And one of the big things that a lot of people want to do is they just want to square everything on the inside. Can't do that. I got to work my way inside out. So I can't do anything right here, so I'm going to go ahead and add the 2. So minus 2 plus 2 leaves me with root x squared, and then I can square it and say x. So I know G is the inverse of f. We have our real one, which lets you know that the other way around, we're going to get a different answer. So I'm going to go ahead and I'm going to write out my other one. So I'm going to get root x minus 2. Root minus 2. Squared. The root and the power cancel each other out, so I have x plus 2, x plus 2 minus 2. I'm led to f, so I know f is. Now, here's the thing. Albeit we got both yeses, slightly misleading statement that we had. G is the inverse of f. They undo each other. But if I were to find the tried and true inverse, what do I get when I try and invert a power? Let me circle this. So when I invert a power, I get a plus or a minus. So f does not have an inverse. So albeit it looks like G is, I know f does not have an inverse. And we'll explore that more in a later section. And there you go.